Assalamualaikum warahmatullahi wabarakatuh. Okay, I'm sorry for I put I put that thing. What is it? The class. I have allocated the class. I have scheduled the class at 3:30, but I didn't know somehow the time for 10 a.m. In the All right, now I just want to remind you that we have the quiz on Wednesday, and the quiz will be about 30 minutes. No, not 30 minutes, I'm sorry, 40 minutes. And I would like you to have your video on. So for the quiz, turn on your video, so that will be a form of invigilation. Okay, so I will know who are taking the quiz, and so that I can at least invigilate the work for that process. So please, for the day, for the duration of the quiz, turn on your video. Okay, all right. So I will continue from here today. We have discussed about the marginal revenue. Actually, for this part, 9.4, 9.5, 9.6, the application is on the marginals, the derivative of a variable, and we call derivative marginal. So marginal, the first example that we were looking at was marginal revenue. Marginal revenue is R prime. That's derivative of revenue with respect to X. We call it marginal revenue. That's derivative. Number two, we want to do the interpretation. How do we describe the marginal revenue? Okay, marginal revenue, what does it mean? Now, in order for us to describe the marginal revenue, we have to use the similar description of what we learned in chapter number 1. So marginal revenue, which is equal to R prime, dr dx. Now, when we interpret, we are making use of, again, the concept that we have earlier, delta R over delta X. In other words, for a function equal to f of x in general, when you want to interpret dy dx, we think of it as delta y over delta x. So we are going to use this to interpret the thing. Yes, can you hear me?
You forget to presenting.
Oh, saya tak buat presenting. I didn't share screen, sorry. Selalu lupa. So if I forget anything, let me know. Lupa. Now I realize that I am getting older. Lupa lah. Sometimes because our class Wednesday to Monday tu lama nggak gap. So lupa lah nak buat Zoom ni. Alright. So when you interpret the derivative of a function, you are going to interpret in terms of delta y over delta x. For example here, marginal revenue. How do you interpret marginal revenue? the interpretation is based on delta R over delta X. In other words, we still have to think of the X increases by 1 unit. So we are talking about 1 unit because in application, there is no such thing as small change. The smallest change is what? 1 unit. So we don't talk about changes of, very, very small increase in X. You can't, okay? Because real things, they change by 1 unit. So if X increases by 1 unit, or if we produce the good by 1 more unit, then the revenue will change depending on the value, depending on the sign of revenue. Okay, will increase or decrease depending on the sign of the marginal revenue. Will change, increase or decrease by how much? By the value of the marginal revenue, by the MR. Example, let's say we got MR, which is equal to R prime, equal to 20. So what does it mean? It means that if X increases by 1 unit, here it's positive. In other words, dr dx is positive. So if X increases by 1 unit, revenue will increase by the value of the marginal revenue, which is 20. All right? Okay. So that is the interpretation of the marginal revenue. We will interpret according to the basic concept. But there is one thing that you need to add. We have to add the point of the derivative, x equal to, say, x0. So you have to mention where you take the derivative, because the derivative of a nonlinear function will never be the same at any 2 points, or it can be the same, but, for nonlinear, mostly it will not be the same. So we have to mention the point of the derivative. All right. So we have to say x equal to some value, or here x0. Then if x increases by 1 unit, or if we produce output by 1 more unit, the revenue will change. Okay, either increase or decrease depending on the sign of the marginal revenue by the amount of, or the value of the marginal revenue. Example, if the marginal revenue is 20, that means if X increases by 1 unit at a certain level of output, R will increase by 20. Right, okay. So in order to see that better, let's look at 9.4. The example that I would like to see is 9.4, the marginal revenue. We'll go to 9.4. The example is example number 10. So go to example number 10, the revenue example. If you have a different edition of your book, probably different example, but we want to see the revenue example. In my book, 11th edition, it's example number 10. So we are given the revenue, which is equal to the function as given in the book. First, you want to see, or you want to find, all right, you want to find the marginal revenue at X equal to 500. Now, as we can see, revenue is a function of X. So when you do this application, we have to specify what is X. Most importantly is the unit, okay, the unit. And then, of course, R is always in dollars. So you have to specify this, what is X and what is R. So if you look at that example, what is X? X is simply the quantity. So here, X is the quantity of the good in units. Okay, in units, just in whatever it is. And then revenue is in dollars. So when you will describe, we must describe in terms of the respective X and R, depending on the problem. Okay? So now you want to find the marginal revenue. What do? You take derivative of the revenue function. So what do I get? I get R prime, where equal to drdx. You don't have to write everything here. I just write it to make us familiar, notation. But if you write, you just use one of these notation. You don't have to write everything. R prime or drdx, what is it equal to? You take the derivative of the function. I got 1,500 minus 0.02. So I write there 0.02 times 2. X. So 0.02, you multiply it by 2, you've got 0.04x. So that is our marginal revenue. Now, you want to find the marginal revenue at x equal to 500. So what do? We substitute the x equal to 500 into where? Into the R prime or into R? 500 into marginal revenue, okay? R prime or MR. Because I want to find marginal revenue. We don't want to find revenue into R prime. So what do I get? I get R prime equal to 1500 minus 0.04 multiplied with 500. What do we get? You just look at the book. We get 1480. So that is the marginal revenue. Okay, 1480. Now you want to describe it. So when you want to describe it, I have to describe in terms of what? In terms of 1 unit increase in X, like I stated earlier. Yeah. All right. Okay. So let's do the description here. So I want you to think a little bit for 1 minute and then describe the marginal revenue at X equal to 500. Okay. Now somebody wants to try to describe the marginal revenue? Anybody? 1480. So how do you interpret the marginal revenue? Anybody? Nih, Haziq nih. Haziq, are you here? Cepat, interpret the marginal revenue. Try. Haziq. Haziq, are you here?
Haziq yang mana, sir?
Haziq ni lah. Haziq Shah.
Oh, Haziq Shah seorang lagi.
Seorang lagi. Yang dalam gambar ni. Saya tunjuk gambar ni kan. Nampak gambar tak? Tu gambar tu. Oh, Haziq ada 2 kan. Okey, Haziq Shah. Haziq mana-mana pun tak apa. Okey, cepat Haziq.
Not quite sure, sir. Sekejap.
Ha?
Sekejap, tengah fikir.
Apa nak fikir? Saya dah bagi time fikir dah. Haziq Shah, you still owe me something. You still have not changed your name. I want you to write full name, Muhammad Haziq. Okay? I think you are the only person who have not write down your name in full. You see how everybody has make the adjustment except you.
No, sir. Every time I masuk, baru dia akan tukar to my short form. So kadang I
Betul sir.
Ya ke?
Memang Zoom punya setting dia akan tulis first name and last name. Kita orang kena tukar manually every time nak masuk
Lah,
meeting.
susah lah macam tu.
Google account pun sama tu.
Yeah.
Kalau macam tu, if you put your first name, then they will come up your second name akan datang dulu Betul?
Yeah.
Betul.
So what you do, you switch your name. You try macam ni. You write your second name tu dulu. Because now I know. They are following the US punya style of names. They will use, we write first name, second name kan. So when they record down, they will go with your family name first. Itu macam tu. So what you do, okay, try ni. You put your second name tu dulu, okay? Your first name, second. If that is the issue. Okay, thank you for telling me that. Tidak penat lah tiap hari nak melukar. So katakan Haziq ni kan. Haziq Muhammad Haziq. Okay, Muhammad Haziq. Sekarang ni, if you write like this is one, that is two, dia akan keluar Haziq juga dulu kan? Betul? Is that
Betul.
right? Okay, so what you do now, you try ni. You try tulis Haziq dulu. Lepas tu Muhammad tu tulis nombor 2. Then they will switch. Muhammad will come first. Okay, so you try Haziq dulu, lepas tu Muhammad. Because I think what they do here, when they put in our name, it will be recorded as our family name. This is a family name. Dia follow nama Mak Saleh. Okay, family name akan datang dulu. Macam John McEnroe. So they when you write John McEnroe, the record will say McEnroe John. So family note, kita try ni dulu. Try macam ni. Tengok macam ni. Nombor 1 Haziq, nombor 2 Muhammad. So kalau ada masalah tu, you buat macam ni. Try. Kalau tak dapat lagi, nanti kelas akan datang ni bagi tahu saya. Tengok macam mana. Kalau tidak nak tukar everyday, penat tu. Okay, cepat. So, interpretation dia macam mana? Okay, anybody lah. Kalau Haziq tak prepare lagi, anybody. Somebody. Okay, go ahead. Tak kira siapa. Try. You know, when we try, don't worry whether it's right or wrong. You try lah. You try what you thought. Okay, after our discussion, try. Salah pun tak apa lah. You know, we don't always try first try. Betul, mana ada orang buat macam tu. Mana ada orang first try dapat betul tu. Unless belajar 1, 2, 3. Tapi belajar 1, 2, 3 tu masa dah 1 pun silap. Pergi kedua 1. Kadang kita sebut 2, 3, 1. So first try tu may not be right. How can you get the first try always right? Okay, cepat. That's why I said try. You know, I don't say give me the right answer. Okay, go ahead.
Okay.
Go ahead, Abu.
Abdullah.
Yes.
Imaginary value revenue will increase 1,480 per unit.
Revenue will increase by $1,000 by $1,480. Okay, but it's not per unit. That is what you are saying is only a part of the whole thing. What is the reason for the revenue to increase? Why? So what you say is correct, but that is not the full thing. So revenue, right, will increase by $1,480. But that is not the whole thing. We have to add a little bit more. What is it?
When X is 500?
But what we're talking about is this DRDX. Okay. What you were saying is only the delta R. Okay.
If
So,
X increase means
You have to say the delta X. If X increases by how much? If X increases by 1 unit. Okay, in application, the smallest
So we have-
increase is 1 unit. Okay, you
in
cannot
our
have,
answer, we have to write it like this.
yes. And then you have to add what? Add X equal to 500, because that is the point where you take the derivative. So if you just say revenue increases by 1480, that is only half of the story. All right. So you want to see why revenue increased by 1.0. Because of what? Because output increased by 1 more unit. I produced 1 more unit output. What about revenue? Revenue will go up by 1480. Revenue doesn't go up just like that. Okay. Revenue will go up because of what? Because of the delta X. Because we are going to describe the ratio. Okay, the ratio. All right. Is that clear? Okay, good. Now, I would like you to get the revenue. Say X equal to 20, 25. Okay, if X equal to 25, what is the marginal revenue? Can somebody compute it? I don't have, yeah, I have my calculator, but I don't want to do that. X equal to 25, what is the marginal revenue? Berapa dapat marginal revenue? X 25.
$1,499.
1,999. 1,199. Okay lah. So it's here at X equal to 25. Marginal revenue is 1495. 1495. 99. So you see there is a difference. All right. So that's why we have to mention the point where you take the derivative at, because the derivative, the value is always different. So when when X equal to 25, the marginal revenue is 1499. So how do we interpret it? Okay, somebody interpret. At X equal to 25, you have to start. You can start. You can say that at the end, or you can say at the beginning, it doesn't matter. But we have to say the point of the derivative. All right, somebody try. How do you describe the marginal revenue? Cepat, anybody? Tak kira lah siapa pun. Okay, Amiratul, Syahira. Okay, try. Amiratul, are you here?
Yes, sir.
Okay, try.
At X equal to 25, the revenue will increase by 1,499.
Okay,
That's all I think.
yelah, itu dia.
Oh, I'm not sure, sir.
Betul lah tu. Okay, betul lah tu. Tapi that is not the whole thing. Revenue increased by 1499. That is not that is half right, you know. You only do it halfway. Okay, continue. Okay, anybody? Finish it up.
If X increased by 1 unit.
If I produce by 1 more unit, okay, if we produce, or the firm produce 1 more unit of output, or simply put, if X increases by 1 unit. Okay, you don't just say revenue increase by that amount. revenue increased by that amount if output is increased by a certain amount. Okay, which is 1 unit lah. Okay, so that is on the marginal revenue. So hopefully we already have some idea on it. Okay, it's increase in revenue. So for your homework, I want to give you a few questions. So go to number 48. Okay, number 50. 48 is on the revenue, 50 on the investment, and then you do number 52, that is on the demand function. So I think that will give us different type of example. All right, okay, so 48, you do. Now, if you look at 9.6, 9.5, I'm sorry, you have similar application or 9.5. You have similar application, just that they are applying the different rules of derivative. So I give you a few questions, on 9.5, everything the same, interpretation the same, examples are on the same concept, just that you need to apply the different rules of derivative. So I give you 43, that is on revenue, but you need to apply probably the product rule, not product rule, the apa nama rule? Not product rule. Yeah, betul product rule lah. The power rule, product rule lah. U times B. Okay, you have to apply that. Tapi yang ni senang je. Maybe you can use this. Okay, so you have 43, and then if you want to do the quotient rule, okay, quotient rule that is 41. So you do 41, 43. 41, you do the quotient rule, 43, product rule. And then I'll give you a few more, you go look at 9.6. Again here, we apply the power rule, the general power rule. And probably, I do not know whether there is a chain rule or not, but that is on the rule. So 9.6, I give you a few questions. Revenue 39, just apply the different rules that you have. And then 51 is on the pricing. And then number 40. So maybe we can try do now. Okay, I want you to do 42. Okay, 42 do now, just for our practice. And we apply the. Okay, for this one, you think, all right? You think what rule do you apply in order to get the derivative? Okay, I give you 5 minutes. Try to do that question. 42, 9.6. It's the pricing and sale. You have sale as equal to 98 divided by the square root. Okay, you do that question. If you have a different addition, probably it's a different number. So do this one, all right? In my book, it's number 42. Okay, do it now. Okay, first, what rule do you use to do the to do the derivative? Anybody? You have S equal to 98, all right, divided by benda tu. So what you do first is the square root is to the power of half. Okay. Anybody who get this? What rule do you use to do that derivative? Are you going to use the quotient rule or are we going to use the product rule?
Question.
If you use the quotient rule, you can. But you know, because you can, but the function is too simple. Because you have a constant just on the top there. Okay, so very simple. You can do that. But what you can do is we can do as a simple power rule. Okay, just use the general power rule by bringing this thing here up. Okay, so you just use the power rule. Okay, okay. No. The first person who get the derivative, let me know so that we can proceed getting the second part of the question. Actually, the second part. Yeah, the second part. You want to find the rate of change at the price 44. Okay, first person who get the derivative, let me know. Okay, anybody got derivative? So how do you get the S prime? What is the rule? You apply the power rule. So what is the power rule? You remember the power rule? Y prime is equal to what? Power rule. You got Y equal to U to the power of N. So what is Y prime? Y prime is equal to N, U, N minus 1 multiplied by U prime. So you have to take the derivative of U with respect to P. Okay? So here, our S prime, what is it? S prime to the S dP. So the S prime is ds dP because you have a variable S and P. So what do you get? If I let U be equal to what? So you let U be equal to the P plus N. So I let U equal to P plus 5. I'm sorry, P plus 5. So what is U prime? P prime. What is P prime? What is U prime?
P.
B. Huh?
B.
No, you have U plus P. U is equal to P plus 5. What is the derivative of D of U with respect to P? Du dP or U prime is 1 because you have only P. So what you do is that you apply that rule. Now the constant will just follow the derivative. You bring down the power, all right? you multiply by that U, reduce the power by 1. So negative half minus 1, that is negative 3/2. But U is equal to 5 plus P. So therefore, it's equal to 98. So now you put in the U lah. You put in the U. So 98 divided by a half, that is equal to what? Negative
49.
49. Negative 49 multiplied by P plus 5 to the power of negative 3/2. So of course, you can bring that back down. Okay, so this is our S prime. Now you want to find what? I want to find the value of this thing here at X equal to 44. So when P equal to 44, okay, you have to find S prime. What do you do? Substitute S prime. All right, so substitute, what do you get? Okay, substitute P equal to 44, 44 plus 5, that will be equal to 49. You bring that thing down, so 49 to the power of 3/2. Okay, 3/2 is 1.5. So see what is the value of the S prime? Okay, first person who get it, let me know. When P equal to 44, you find it, you show the work lah. Okay, show the work, but you do the work, give me the answer only. S prime equal to berapa? Okay, here.
I'm not sure, but it will be negative 0.14.
Negative 0.14. Okay, somebody else. Do you get negative 0.14 or you get something else? So you will get, okay, negative 49 divided by 44. 44 plus 5. It's also 49. 49 to the power of 3/2, which is 1.5. So 49 to the power of 1.5, berapa dapat? Okay, anybody? Betul ke S prime ni? Ni, check. Jangan tulis saja 1.4. I want you to do it, okay? And check whether this is right or wrong. Okay, next person. Do you get the same value or you get different value? Let me know.
Okay, I do it in 2 ways. It's correct.
Both ways correct. Okay, I want to reconfirm. Another person. Check this. What is your answer?
Same, negative 0.14.
Negative 1.4. Okay, all right, good. So assume that is correct because we have two people getting the same answer. So next is, how do you describe it? Okay, interpret your answer. There is part B. So you have to go back. What is S and what is P? So you know that P is what? P is the price. So I write down here, we know the P is the price in dollars. So price is in dollars. And then what is the S? S is what? S is the sales volume. So S is the sales volume in what? In thousands of dollars. So the unit, okay, unit is not just dollar. Unit is in thousands of dollars. So 1 unit here is equal to what? Equal to $1,000 lah, $1,000. So I have here negative 0.14. All right. Okay. So we go with the basic unit. Negative 0.14. What does it mean? It means this is ds dx. When we want to interpret, we interpret it in terms of delta S over delta X, just like what you did for the revenue. Okay, but you have to mention the point of the derivative. Okay, so describe the marginal sales, or in other words, S. Okay, somebody try. Tak apa. Anybody can try. You know, it can be wrong, it can be right. After that, we will go through. Okay. Somebody. Okay, Hima. Try describe that thing. The value is 0.14. All right, what does it mean? Hima, are you here? Okay, Abdul Latif. Try. Abdul Latif Ma'an. Abdul Latif. Oh. Abdul Latif, you know, your name as in the list is not Abdul Latif. Your first name in the list is Al Hajim. So you're looking at Al Hajim lah dulu. Okay.
I see. No, because because my Al Hajim is actually my family name, not my actual first name. That's why.
No, it doesn't matter lah, because I said you must write your name according to the list I have. Okay.
All right, then I'll change it.
You don't understand what I said. Okay. You write your name according to the class list. I don't care lah what is your name appear in whatever order. Okay. Just write it according to the list, class list. Your class list, the first name that appear is Al Hajim. It's not Abdul Latif. Okay. So because I didn't remember Abdul Latif. So you have to put it Al Hajim dulu lah. Okay, put Al Hajim first. It doesn't matter, right? Your father's name, your family name, Al Hajim, but that is how it's written. Al Hajim come first. So you put Al Hajim before Abdul Latif, like that. Okay. Describe that S prime. Al-Hajim, Abdul Latif. Okay. But I will call you Abdul Latif, correct? But your name is Al-Hajim first. Okay, describe it. There is another student, Al-Awadi Ziad. So I have to check. So in that case, you know, Ziad, you also have to write Al-Awadi first. Okay. All right. Shahira, describe that S prime. Okay, cepatlah. Try. Go ahead. Describe the S prime. Negative 0.4. Try. Come on, try. Takkan tak dapat apa pun. Okay, at least you know a little bit. So share that little bit you have. Shahira, back. Shahira, are you here? Okay, go ahead. Do I have to unmute? Tak payah lah. You can unmute by yourself. Tak payah saya unmute. Okay, come on. Nurul Hana. Can you try Nurul Hana? Cepatlah, ada 3 orang saya sebut ni. Takkan nak tunggu sampai habis period ni. Cepat. Somebody.
Sir, can I say something?
Yeah,
It's an
sure.
idea. I'm not
Okay,
sure
go
if it's
ahead.
correct, but
All right, go ahead.
okay. Seeing that S is negative, right?
Yes,
So wouldn't that mean sales have declined in a way?
yes. Okay.
And since we're using P instead of using like the previous the normal terms, so since we're using P and S, so that means when P is at one point, then the sales would have declined by negative 0.14.
Okay, the sales will decline by, when you say decline, you don't have to mention negative anymore. Okay.
Just say 0.14.
That means sales will decline by 0.14. Okay, 0.14 what? What is the unit?
141.
14 what? What is it? What is the unit of the sales?
Dollars, right?
Dollar. Okay. So sales will decline by 0.14. It's not just dollars, it's $1,000. So sales decline by 0.14 thousand dollars. Okay, $0.14,000 because that is the unit for the sale. Okay, so that is half of the story. Can you complete the story? Finish it up. Okay, I think so see here, sales is $1,000. Okay, so this 0.14, not just simply dollars, it's $0.14,000. So $0.14,000 is what? 0.14 you multiply by 1,000, what do you get? You get 0.14 of 1,000 is what? For 140, yeah, $140, or is it $14? So I'm not sure. You can calculate. But sales decline, so I just write down sales decreases or decline by how much? By $0.14,000. Okay, good. Okay, somebody else finish it up. That is not the whole story yet. That is only half of the story.
I wanted to give the finish, but it's fine.
Okay, go ahead.
But also, I'm also unsure of this, but
That
considering
doesn't
what we're
matter.
doing with my
You try,
lifetime,
okay?
so sales
Trying
decline
is
by-
better than don't try at all.
All right,
Okay,
so
finish.
wait, is it sales declined by $0.14,000 when one more unit is produced?
When, okay, when what? Now you look at the independent variable. Is it output or is it what?
Oh, it's price.
The price. So you must do it in terms of the price. So what happened to the price?
When price increase?
When the price increased by how much? By, what is the unit for the price?
Dollar.
By $1. by $1. Okay.
I see.
Uh,
Okay.
So it's not that difficult. Okay. We just follow the pattern. You have the interpretation is according to the delta S, delta Y, delta X. That's the general one. So here you have delta S. Okay, delta S or DSDP. DSDP meaning here is no X lah. I'm sorry, I shouldn't use X. It should be P. So P. So that means the price according to the units that you have. So when price increases by $1, where do you take the derivative at? So you have to finish it up at what? At P equal to how much? $44. Okay, so that is the full description. Okay, all right, good. So like I said, you know, when we say try, it doesn't mean correct. It can be right, it can be wrong, you know. So try aja lah, hentam je lah, janganlah hentam. You try with some thinking. It can be right, can be wrong, so it doesn't matter. We are going to discuss it anyway. Okay, macam tu lah. That's how we learn. You know, when you learn, that means we commit mistake first. Okay, so I will meet again after the azan. All right, I'll see you again after the azan finish. All right, okay. Okay, Assalamualaikum. So, are you clear on this? Okay, okay, good. So now, give you already some questions on 9.6. So I think that will be enough. Let's move on. Okay, the application that I would like to, there are more applications. Okay, more applications in 9. Berapa tu? Alamak, saya susah ulang. 9.7. 9.7. 9.7, 9.8. Okay, you go to 9.7. 9.7. Yeah. 9.6. There are more applications on 9.9. I'm sorry, 9.9. 9.9. So if you look at 9.9, the applications that we already have considered, the marginal revenue, okay, we already did that. Second example number 3 is the marginal cost. So you have a cost function, and then you want to take the derivative. The derivative is marginal cost. So let's look at example number 3 on 9.9. So 9.9, more applications. Actually, the applications we already know. So you just read. So, okay, you read the marginal revenue. I will just go into the one that we haven't done, example 3. That is the marginal cost. So if you have the cost function, as per example 3, you have the cost is a function of x, where x is the output in units, whatever the units are, and then the cost is in dollars. And the cost function is given. So as you can see here, the output is kitchen blenders. So for this example, the X is output. That means you can say X is the quantity of kitchen blenders. Or in short, we just put kitchen blenders. Okay, kitchen blenders in unit. This is just unit, kitchen blenders in unit. And the dollar and the cost is of course in dollars, just like revenue. So if you do the marginal revenue, what do I get? I get the derivative of the cost function. So you can see part A. Okay, part A, you will see the derivative of the cost, that is the marginal cost, which is equal to C prime or dC dx. So that is the derivative. That is part A. Okay, everybody look at part A. So you got the marginal cost, and then we want to interpret or describe the marginal cost when x is equal to 80. So for the first one, x equal to 80, and then the second, they give you x equal to 200. So as you can see there, what is the value for the marginal cost when x equal to 80? 3.2. When x equal to 200, what is the marginal cost? 32. You see, there is a big difference there, 3.2 and 32. So now what I want to do is you want to describe it or interpret. So describe it in terms of cost, okay? So you have marginal cost equal to what? Equal to dC dx. Yeah, when you want to interpret, we have to look at it delta C over delta X by what? Per unit increase in X. What happened with the cost? Okay, so at X equal to 80. All right. Since we have done this a few times, by now I think you should be able to do it. So at X equal to 80, how do you interpret the marginal cost? Anybody? Okay, cepat. Anybody? Tak payah nak sebut nama lagi dah. Okay, cepatlah. At x equal to 80, what happened? Dah kena sebut nama juga ke? Okay, Shima Matul. Try. Okay, Aisyah. Tadi Syahira sudah sebut dah. Okay, Aisyah. Tak apalah, siapa pun boleh. Right. Okay. Muhammad Lukman. Muhammad Lukman, are you here?
Yes, sir, but
Okay,
I'm not
cuba.
sure.
Cuba, hentam je. Bagian
I'm not so
hentam,
sure.
fikirlah sikit.
Dua minit, sir.
Try. Cepat, go ahead. Lukman, cakap nak cuba ni. Cuba lah.
No, sir, I'm quite confused.
Tak apa, confuse lah. You just say what you have. Go ahead. It's okay. You know, we will go through it. Okay, cakap. Cepat. Confused? Tak boleh nak cakap apa-apa. Okay, Muhammad Abid. Saya dah sebut Muhammad Abid. Okay, Muhammad Abid. Muhammad Abid. Okay, Anissa Syahmina. Bagus juga saya sebut nama. Boleh check attendance. Okay. Okay, cepatlah. Aisyah. Aisyah ni satu lagi. Aisyah, your name is not Aisyah kan? Your first name is not Aisyah. Saya tak jumpa pun your name under A. Your name, ada Aisyah ada. Okay. Aisyah, berat.
Yes.
Okay, go ahead. Describe lah benda tu. Describe the marginal cost. Cepatlah. Try. Okay, my Chengzhen. Is that how we say your name? My Chengzhen. Is that right? Yeah. Okay, go ahead. Try.
I don't know how to do it.
Huh?
I don't know how to do it.
Yeah, you try. Go ahead. What you have? Okay. Nur Soleha. Okay, Nur Soleha. So now you have to interpret in terms of what? C and F. Okay. So Nur Soleha. Try. Go ahead. What you have?
Cost will increase by $3.20 per unit.
Okay. All right. Cost will increase by $3.20. Okay. That's not the whole thing. What else? What else do you have to say?
When the production of blenders increase by 1 unit at X equal to 80.
Betul lah tu. Okay, everybody listen to her. Everybody hear her. So that's it. All right. At X equal to 80, cost will increase. Okay, cost will increase by how much? By $3.2. So when you say cost increase by $3.2, you don't have to say per unit too, because per unit too is the unit for the marginal cost. Cost increased by $3.20 if production increased by how much? You say production increased by production of blenders. Okay, I think I have to write what she said. Production of blenders increases by 1 unit. Okay, so that's it. You see, she say production of blenders. That's good, because I normally say when we produce 1 more unit of blenders. So I normally say we produce 1 more unit of blenders. Okay, which is correct. Yeah. But she said production of blenders increased by 1 more unit. Okay, that's good. Okay, so that is the interpretation of the marginal cost. And of course, for the second part, if X equal to 200, all right, and X equal to 200, you will see the marginal cost is equal to $32. So you interpret again. Okay, so I want you to interpret. So now, okay, do it at home. So that is the application of the derivative. So what we did is we did the derivative of a few examples, revenue, cost, and I give you also a few questions. And to interpret the derivative, we just use what? We just go back to use the delta y over delta x. X increases by 1 unit, because in application, that is the smallest increase. You cannot have a blender increase by, if you look at the derivative, the x will increase by how much? By a very, very small amount. Okay, very, very small. Very small quantity, it's a small amount. You cannot have that in application. So we have to go back to the basic concept. To estimate the change, we use the derivative. And how to describe it? We describe it by change of the independent variable by 1 unit. All right? Okay. So that is the application. Now, what I want to look at next is the first derivative test. That is what we call the first derivative test. Now, first derivative is derivative. So first derivative, you've got y is function of x, y prime, the derivative of the function, you call it y prime equal to f prime of x. That is the derivative. Ni lah, derivative ni, we call it first derivative. So when we just, normally we don't say first derivative, we just say the derivative, okay? But the reason why you say first derivative, just to differentiate, because we have second derivative and you have third derivative. So there will be a few more, okay? Just like cousin, if your cousin, you don't say first cousin, you just say what? We just say cousin, yeah. But when you say cousin, meaning what? Meaning first cousin. And you have second cousin, you have third cousin, you have fourth cousin, and so on. So first derivative means just the derivative. We say first derivative because there is a second derivative test. So first derivative refer to using just the derivative to test. So here we are using the derivative we are going to use the derivative to test for maximum. So here we're going to use the y prime equal to f prime of x to test whether, okay, to test whether a function y equal to f of x has a, normally we say relative, but for us, we don't need that. Relative maximum or minimum at a certain point. So that is what we want to establish. We're going to use y prime to relate or to determine whether our function y equal to f of x has a maximum or minimum at a certain point. Okay, so what is maximum minimum? If you go to where? To 10.1. Okay, you go to 10.1. Okay, go to 10.1 because this is 10.1. And then after that, I will go back to chapter 9. Now you go to 10.1. Look at the figure 10.1b. 10.1 A ada, B ada. Okay. You've got 10.1A, 10.1B. Tak ada. Itu dia. Alright. Okay, just go to 10.1b. Tengok B dulu. Okay, if you look at the diagram, you look at the function. Okay, don't worry about the equation. Just look at the function, where the curve, how the curve looks like. In B, you will see that at the point 1, -4. Okay, 1, -4, if you see the function, that is what? That is the lowest point. Okay, that is the lowest point. So what you say, that is a minimum. Okay, that's a minimum. And then if we have something like this, I draw it because it's not shown there. If I have something like that, okay, y equal to f of x, at that point somewhere here, that point, okay, you have what? You have a maximum. So that is what you mean by maximum or minimum. So we're going to make use of the first derivative to see whether the function has a maximum or minimum. Okay, all right. So in order to do that, there are a few things that we need to know. Number one, I want to relate. Okay, I want to relate y prime, the behavior of y prime, to the function. The behavior of this y prime, how does y prime behave? Okay, behavior of y prime to the behavior of y. How do they relate? Okay, how do they relate? Okay, number one, if we consider an interval, but I'm not talking about interval first. We just look at the direct relationship. If, all right, y prime is positive at any point, then what about y? Y increases. So that is number one. Okay, if y prime is positive at any point, then the function will increase. Okay, will increase at that point. At that point. To make it more general, if y prime is positive at any interval because there are so many values, okay, there are many values. So we say y increases over that interval. So first, I was talking about 1 point. Secondly, since there are many points, we are talking about interval. All right. Okay. So let's look at some pictures to see it. So if I draw a graph, something like this. Let's say I have a function going like that. Y equal to f of x. Okay, suppose I look at one point here. Say x1. That is y1. Okay. Look at the derivative. Okay, derivative at the point. That means the slope at a point. Now, what can you say about the derivative here? Y prime. What can you say about the y prime? For that matter, I can take any other points. I can take over there, over here. Now you can see a regular characteristic of the derivative or the slope at a point. What is it? Okay, anybody? Apa? Come here, cakap. What can you say about the y prime at all these points? Huh? What? Okay, cakap. Huh? Y prime?
Has a shorter slope.
Y prime is, of course, slope at any point. Okay, we know that already. But what is the characteristic of this y prime at these points, at all these points that I draw the slope? What can you say about the slope at each of these points? You look at it, tengok je lah. Derivative kat sini, derivative sini, derivative here, derivative over there, derivative over there. What can you say about the y prime? What can you say about the pink straight line? Huh? If the slope is like that, what do you say about the slope? Macam ni, if the slope is going up like that, okay. So what do you say about the characteristic of the slope? Ni, kalau slope macam ni, apa you cakap apa? Ni M macam tu kan? Or M macam ni. What do you say about that slope?
Positive slope.
Positive slope. So here you will see all these points. There is only one character of the y prime. Y prime is positive. Okay? You look at that point, look at that point, that point over anywhere, the slope is positive. Now you look at one point at x, say at x1. The derivative at x1 is what? Is positive. Okay? So therefore, what about y?
Will increase.
Y will increase. Okay? You think of this way. Y prime, okay, y prime is dy dx. All right? Now, dy dx is positive. X increases by small amount. Okay, by a small amount. X increases by small amount. Now, if the slope is positive, what about y? Will y go up or will go down?
Down.
Mana pula y go down? If the derivative is positive, if x increases by 1 unit, by a small amount, if x is positive, all right? You say x increases. Then what about y?
Y increases as well.
Y also increase because the derivative is positive. Okay? The x positive, dy positive. So y will increase by a small amount, y increase. So therefore, y will increase. Y increase. All right. So in short, if the y prime is positive, we just say y will increase. If your CGPA this semester increases from last semester, what about your CGPA? Will your CGPA increase or your CGPA go down? Increase. GPA, okay, is what you get now. CGPA is the function. Okay, CGPA is your function. It's the accumulation. GPA is what you get currently. Okay, so katakan GPA last sem. Last sem your GPA is 3.1. This semester your GPA is 3.2. So there is an increase over there. Delta X increases by how much? 0.1. Okay, to make things better, kita increase banyak. 3.8. Okay, you get A in business math. Right? 3.8. So delta X increases by 0.8. Your GPA increased by 0.8. If your GPA increased by 0.8, what about your CGPA? Takkan your CGPA will decrease. Your CGPA will go up. Okay, so as simple as that. So if our slope is positive, X increases, what about Y? Y will increase. All right, so we can generalize this over an interval. If Y prime is positive at any interval, therefore the function Y will increase over that interval. So I can put one interval from here. You know, one interval from this point. One interval over there. So you see here, the slopes are positive everywhere. So what? In that interval, Y prime positive, that means the function increases. All right. So that is relationship number 1. Okay. Now, since I take a few more minutes because the other one will be related to this. So if I delay until next class, we may forget. So with the same idea, if Y prime is negative at any point, okay, at any point, or at an interval, then what about Y? Will Y increase or will Y decrease?
Decrease.
Y decreases, decrease, okay, at that point. Or if you're talking about interval, over the interval. All right, so again here, I draw you the graph. Let's say the function will look like this. That is Y equal to f of x. Now we draw the slope at any point. So I can start from here. I cannot touch the line. So if you draw it nicely, touch the line. So what can you say about the Y prime here? Over here, over here, over there, up to here. What can you say about the Y prime?
Negative slope.
Negative. Okay. So if Y prime is negative, what about Y? No, that is actually decreases. It's actually straightforward from the graph. So Y decreases. Now, how do you explain it? We look at dy dx. So dy dx is negative if I increase x by small amount. All right, if x increases by small amount, dy positive. Okay, now dy positive, dy dx, the slope is negative. So what about dy here? Positive or negative? X increases. Okay. Now, what would be dy?
Positive.
Negative.
Negative lah. Okay, because dy dx is negative. Dy dx less than 0. So if dx is positive, that means x increases by some amount. Dy will be negative. So in other words, y will what? Y will decrease by some amount. So y decreases. Okay, just like your CGPA. If your GPA now is 3.0, I mean, last sem is 3.0, this sem, your GPA is 2.5, then what happened to your CGPA? Going up or going down?
Down.
Going down. Okay, think of it like that. Lah. Okay, so dy dx is negative. That means if x increases by some amount, small amount, then y will decrease by some amount, or just say will decrease. So in short, okay, in short, y prime negative, the function decreases. So you just draw the graph, sketch, okay? Sketch the graph, you see negative slope, that means the function is decreasing. All right, okay. So this is the basic idea, okay? How the y prime relate to the y, to the function, that's the basic idea. And next time, we will go into the proper interval, all right? The proper interval, and we can formalize the relationship. All right, so I'll stop here. Sorry to take a little bit longer than necessary. I should end it by 10 minutes ago. So I'll see you again. Have a nice time. Study, okay? Study. Don't worry about the homework I give you today. For today until Wednesday, study for the quiz. Okay, study for the quiz. Don't worry about what we learned today. What we learned today, postpone until Thursday. Thursday, study balik. Okay, so I will see you again. Assalamualaikum warahmatullahi wabarakatuh.
Sir,
Waalaikumsalam.
Okay. Yep.
sir, about
Yeah.
the quiz, it will be in Google form or
Yeah. Quiz ni macam ni je. The quiz we do it in class. Okay, I don't know the Google form. We do the quiz in class. That means yeah. Tak payahlah, saya tak payah. Yes. We do it in class. Okay, I'll give you the question. I show you the question on screen. You do it. And then, like I said earlier, for invigilation, I need you to turn on video. Okay. After that, submit through WhatsApp. I'm sorry, bukan WhatsApp. Submit to Classroom. Okay, you submit to Classroom. Okay. Tak payah. Apa nama tadi? Guna apa? Google apa?
Google form.
Google Form. Saya tak pandai guna Google Form. So kita buat in class, macam in class lah. Okay, I will show you the screen, the question. You do it on your video. After finish, submit to Classroom. Macam biasa. Okay? So tak ada cara lain lah, itu je. One method. Okay, any other?
Sir,
Yes?
how many questions?
How many questions tu, I don't know. Maybe quiz is a short thing. Okay? Quiz is a short thing. Normally, 1 question, 2 question, 3 question, but not 5 question. Okay, quiz is a short thing. Okay, easy. Okay, quiz will be easier, short, but I give you about 40 minutes. Okay, even though it's short, but maybe if it is shorter, I give you half an hour. Okay, so it will not be more than 40 minutes. So I'll give you enough question for 40 minutes. Okay, all right. Anything else?
Thank you, sir.
Okay, good.
No, sir. Thank you.
All right. So I will see you again. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
Thank you,
warahmatullahi
sir.